x squared dy dx is equal to 4x squared minus x minus 2 over xy plus x plus y plus 1. The first thing we should do in this ODE is to factor what we can factor. In regards to the numerator, we're pretty much stuck with that. I suppose we can complete the square, but that's going to lead us nowhere. On the other hand, the denominator we definitely can factor by grouping. So note that xy plus x plus y plus 1 can be factored by grouping, because notice this expression and notice this expression. We can factor out an x, so x times the quantity y plus 1 plus this y plus 1. And we can think of that y plus 1 as just multiplied by 1, so this implies we have the quantity x plus 1 times the quantity y plus 1. So this can be re-expressed as this. And so now we have x squared dy dx is equal to 4x squared minus x minus 2 over the quantity x plus 1 times the quantity y plus 1. And we can separate our variables pretty straightforwardly. We have this y plus 1. If we multiply y plus 1 on both the left-hand side and the right-hand side, we'll move that over, so to speak, to the left-hand side to get all our y's there. If we divide everything by x squared, multiply everything by dx, all the x's will be on the right-hand side. So thus we have the quantity y plus 1 dy is equal to 4x squared minus x minus 2 over x squared times the quantity x plus 1 dx. And then we can integrate. The left-hand side is pretty simple. The right-hand side is not so simple. We're going to have to do a partial decomposition, so to speak, of that into fractions. So if we have 4x squared minus x minus 2 over x squared times the quantity x plus 1, according to our partial fraction algorithm, this would be a over x to the first power plus b over x to the second power plus c over x plus 1. It's an interesting question why this works. Now obviously, once we solve for a, b, and c here, we can show that the left-hand side and the right-hand side are equivalent. However, how do we know that algorithm works? That's a much more tricky question, it turns out. And it's not so straightforward. But in any case, let's think about this right-hand side. If we were to add these fractions, we obviously need a common denominator. So for a, we'll times this by x on the numerator and denominator, and by x plus 1. For b, we would have to times it by x plus 1. So x plus 1 on the numerator, x plus 1 on the denominator. And for c, to add this fraction, we'll have to multiply the numerator by x squared and the denominator as well. And so we have 4x squared minus x minus 2, we're just thinking about the numerator, is equal to a times x plus 1. It's a better idea, much better idea, to keep these factored, plus b times x plus 1 plus c times x squared. And then we can create a system of equations. Thankfully, if we strategically pick values for x, we can eliminate some variables. So it's pretty straightforward. Otherwise, it would be much more difficult and tedious. The first thing we can try is x equals 0, because if we substitute 0 in, this a would go away. A times 0 is just 0, and this c would go away. So that's a good first start. So the left-hand side, we substitute 0 in there, so then we're just left with minus 2 is equal to what? B times 1, so B must be minus 2. And then we can try minus 1, because that will knock out A and B. So the left-hand side is first, so that's just 3 is equal to C times minus 1 squared, and so C must just be 3. And then we can just pick 1 for x, And then we would get, on the left-hand side, just a 1. And so we have a, so 1 plus 1 is 2. We can substitute that b in, so minus 2, and then 1 plus 1, 2, plus c, that happens to be 3, and that's 1 squared. So then we have 1 is equal to 2a minus 4 plus 3, so a must be 1. So we have our a, our b, our c. Now we could rewrite our expression. The left-hand side is the same thing, the indefinite integral of y plus 1 dy is equal to the indefinite integral of 1 over x minus 2 over x squared plus 3 over x plus 1 dx. The left-hand side is very straightforward. So we have what? 1/2 y squared plus y. Take the derivative of 1/2 y squared, you're back at y. Take the derivative of y, you're back at 1. And that equals, let's break this up. So we have the integral dx over x minus 2. Well, here we have over x squared, but this could be rewritten as x to the minus 2, same thing. And then plus 3 times the indefinite integral dx over x plus 1. Let's just work on this right-hand side. So here, this is just a natural logarithm of the absolute value of x. Then minus 2. So we have x to the minus 2 power. Add 1. That's just minus 1. So this is over a minus 1. So x to the minus 1 plus 3 times the natural logarithm of the absolute value of x plus 1 plus some arbitrary constant, c. So now we have 1/2 y squared plus y is equal to the natural logarithm of the absolute value of x plus 2 times x to the minus 1 power. We can leave it that way, that's fine. Plus 3 times the natural logarithm of the absolute value of x plus 1 plus c. And this is a good implicit solution.